So this is a course on oceanography, but you obviously cannot complete an introduction to oceanography without worrying about global warming and its impacts on the ocean. We did that. And you cannot do global warming without worrying about carbon dioxide, and we did that by thinking of it as greenhouse gas, its impacts on energy balance, invasion of anthropogenic carbon dioxide into the ocean, and we mentioned biological pump, solubility pump. We looked at the air-sea CO2 flux, but we didn't formally do a carbon cycle. So I took a chapter on carbon cycle from this book called The Earth System by Comp, Casting and Crane, and I will just give a brief introduction to carbon cycle, which should be very useful. Just to remind ourselves, we know that one of the important factors to consider in terms of the impact of increased carbon dioxide in the atmosphere from anthropogenic activities onto the ocean was the so-called ocean acidification. We went through the equations. I'm just going to re-emphasize some of the points here. So here is some data collected from specimen 1, where they looked at the mean shell thickness, and we know the CO2 concentration then, and the ocean pH, so 280 ppm and 8.2. And when in 2011 another sample was looked at, a specimen was looked at, there is a tremendous change in the mean shell thickness. Remember, we said calcium carbonate shell forming animals are going to suffer, coccoliths, corals, etc. Right? So there is a 70% reduction in shell thickness from 1875 to 2011. Of course, you have to remember that there is detection and there is attribution. So attribution here is fairly straightforward. There is an increase of CO2 concentration in the atmosphere of almost 120 ppm. Obviously, by now we are over 415 ppm, so we keep increasing. And the acidity has increased by 30%, which means the pH has decreased by that much, right? Remember, this is a log scale. Okay, so that was the main thing. We also talked about physical impacts. Just to look at briefly again, there are places where the warm currents and the cold currents are being impacted because of lower salinity due to glacier melt, more rainfall, meltwater from sea ice, and so on. And in the deep tropics and subtropics, we have increased salinity because of higher evaporation from warming the atmosphere, because warm atmosphere holds more moisture and that facilitates more evaporation. So the Great Ocean Conveyor Belt is shown here, and the melting polar waters are adding fresh water in the deep water formation sites and reducing the deep water formation and weakening the ocean currents, weakening the global thermohaline circulation. And we had seen that when you look at the global map of warming, there was a so-called warming hole here where there is actually a bit of cooling. So there is one of the main factors. There are other factors, atmospheric water vapor. If you increase warming and you increase humidity in the atmosphere, evaporation becomes harder, because the evaporation depends on the difference between saturation humidity at the surface and the air humidity above, right? So thermal expansion, so the contributions have been estimated between 1993 and 2010, the so-called satellite period, where the thermal expansion of 1.1 millimeter is seen, just the thermosteric impact that we talked about. The heat is penetrating the ocean. Ocean takes up more than 90% of the excess energy from anthropogenic heating. We've said this many times. We have to say it again and again. So the thermal expansion is 1.1 millimeter. Glaciers contribute almost the same amount, 0.86 millimeter, with 0.3 millimeters coming from Greenland ice sheet and 0.27 millimeters coming from Antarctic ice sheets, and the rest coming from the others, right? So this is the introduction, and also we mentioned the biological impacts. Marine species, as we mentioned, on land we can easily see the movement of plants, grasses, butterflies, birds, insects like mosquitoes, and so on. It's much harder in the ocean because we don't have that much data, but still, with whatever data we can see that marine species are moving deeper and towards the poles to escape increasing temperatures. So this is showing a map of 75 species in the North Atlantic coast between 1973 and 2019. Very simple introduction. I'm not going to go into details. Atlantic cod is already overfished. There was a fishing pressure, and the warming seas make it harder for the young to survive. Remember, we talked about physical impact of the food supply, of their own physiology, of the survival of the eggs, the larvae, the juveniles, and so on. So here it is talking about Atlantic cod larvae to survive, the juveniles to survive in water, warm waters. 84% of all species have moved deeper or northward towards the poles, or both. So they have moved deeper and northward. Black sea bass, for example, is a species that had moved nearly 200 nautical miles since 1973. Okay, so we are talking about serious impacts, and these are multiple impacts. We continue to put fishing pressure, we continue to acidify the waters, we continue to warm the oceans, and the physical, biological, chemical impacts are all going to be integrated by the ocean, and the marine species are going to feel the impacts at all levels.